This is Dr. Sajja Suneel from Data Science Department, Institute of Aeronautical Engineering. Today, I am going to discuss with you about IoT physical devices and endpoints. A small revision about this particular module in the course of Principles of Internet of Things. In this Internet of Things, physical devices and endpoints are playing a major role. Why? Because physical devices are the devices which are going to be fixed. From those physical devices only, we are going to extract the data with the help of sensors, the help of actuators, and that data is going to be stored in cloud. And by using that data, we are going to analyze the things and we are preparing a decision based on that particular data. And coming to the endpoints, there are some endpoints where the data has to be virtualized. And today's class, I'm going to tell you about these IoT endpoints and these physical devices which are existed in this particular IoT. Have a look, guys. In this module, we are having few topics such as introduction to Arduino, introduction to Raspberry Pi. In this, the things which we am going to discuss with you today was installations of these particular devices along with the physical things, interfaces. There are three different types of interfaces, which are serial interface, SPI interface, I2C interface. Serial stands for serial communication, which is UART. And the next one is SPI, next one is I2C. Anyway, you are going to see those interfaces in detail in the coming slides and have a look towards the programming, which is the next topic, which is related with Python programming. By using this Python programming, how we are going to configure this Raspberry Pi. And also, we are focusing on the interfacing external gadgets. And also, you are going to control the output by using these things and also reading inputs from the GPIO pins, which are graphical processing input and output pins, which are existed. First, before starting about this particular discussion, I just want to tell you what exactly a particular IoT device was. An IoT device is a physical object that can be connected to the internet, and to share the data also, that particular object is required for us. And have a look, guys, how this particular IoT device is going to be helpful. And here, which this physical device is contains with sensors, actuators, and network connections. I will let you know with some examples. There are thermistors, there are wearables, there are home assistants, there are industrial sensors. There are multiple key components which are existed in an IoT device, such as sensors, actuators, network connectivity, and processing units. These are the key components which are existed in IoT device. Coming to the first one, sensors, which are the major things which are like eyes and ears. Why? Because these are the things which are collecting the data from the physical world, such as temperature, humidity, light, motion, whatever you can call it as. And coming to actuators, these are the things which controls the physical devices, such as motors, lights, and walls. Motors are used to rotate the things, and lights are used for smart lighting purpose, and the walls are used for opening the wall by using the authentications. And coming to the network connectivity, which enables communication with other devices and systems. With the help of this connectivity, only those are transferring the information from one to other. And coming to the processing unit, this processing unit, here it is going to process the data and perform multiple calculations, guys. That is about the processing units. These are the key components which are existed in IoT device. And I will let you know few more things which are related to this. Why? Yeah, I'll let you know few more things which are related to this. Have a look, guys, how the things are and what are the different types of devices and what are the different based on that particular function, what are the different types of IoT devices which are playing a major role. IoT devices are categorized based on the various criteria such as functions, industries, and its sizes. Here I will tell you a common types of things based on functions: sensors, actuators, wearables. Sensors are used in functions by collecting the data from the environment, which I told you earlier. Actuators are the things which control the physical devices such as motors, light, valves. And coming to wearables, the devices which are weighed on body like your smartwatches, fitness trackers, health monitors, all these things comes under wearables. And home automation devices, these are smart thermostats. Like by based on this smart thermostat only, the temperature reading will be known to you, and that sends to actuator. Then that actuator makes your air conditioning system into the room temperature. Smart lights, smart speakers, smart security systems, all these things. And coming to the next one, industrial IoT devices. Sensors and actuators are used in manufacturing, logistics, and energy management. These are the functions related IoT devices which are used. And coming to automotive IoT devices such as connected cars with features like remote diagnostics, informant, and autonomous driving capabilities. These are the different types of IoT devices which are used on a specific function. Now we will see what are the IoT device by based on industry, guys. By based on industry, healthcare system, agriculture, retail, logistics, energy. These are the things which are based on industry. Coming to healthcare, wearable medical devices. Coming to agriculture, farming equipment. Coming to retail industry, inventory management, smart shelves, all these things comes under smart building, even smart billing, even in retail industry. And coming to logistics, smart containers, vehicle tracking, and supply chain management, all these things comes under logistics. And coming to energy, smart grid energy system, energy management system by using voltage sensors, etc. And coming to based on size, there are three different types of IoT devices by based on size, which are microcontroller, single board computer, embedded systems. Microcontrollers are the best examples for Arduino kit. Single board computers are the best example for Raspberry kit. And coming to embedded systems, integrated systems, which are found in various types of devices. These are the based on size IoT devices. Till now, we have seen three different kinds of devices based on size, based on industry, as well as based on applications. Those are the things which we have seen till now. Once have a look what are the things which are existed in a single board computer by based on these IoT devices. Have a look. This is a single board computer which is existed in an IoT system. This is the bus which is interconnecting multiple things: connectivity, processor, graphics, audio, video, memory phases, storage interfaces, and multiple communication interfaces. All these are a part in a single board computer which is Raspberry Pi. Block diagram of a specific IoT device it was. And coming to IoT physical devices and endpoints, here you need to understand what exactly physical devices and what exactly endpoints are. IoT physical devices are the tangible objects which are equipped with sensors, actuators, and network connectivity, which enables them to interact with the digital world. And coming to the endpoints, which is an IoT content which refers to termination of a particular communication channel. There are n number of devices which are connected with themselves and which are going to interact with them. For instance, a cloud platform where the data is going to be stored and processed without considering an endpoint. This is it. And coming to key components which are existed in this particular things, the same things which we discussed previously, like sensors, actuators, microcontrollers, connectivity, power source, all these are the key points which are existed. And what are the examples of these physical devices? I already told you: wearable devices, home automation, industrial IoT, automotive, agriculture. These are the best examples for IoT physical devices. And what are the challenges and considerations which we are going to face at that particular point of them? The first challenge was security, and the second one is power consumption. Third one is data privacy, and coming to the fourth one, interoperability, and coming to the fifth one, scalability. These are the different types of challenges which we are facing. And also we need to consider a specific popular platforms for our IoT project implementation, such as Arduino, which is an open source platform for prototyping and building electronic projects. Coming to Raspberry, which is a credit card sized computer for building various kinds of applications, including IoT. And coming to ESP8266, which is also called as ESP32, which is Wi-Fi microcontroller with low power consumption mode. These are the challenges and considerations which we need to compare. And once again, I'll start with introducing the same things which we have seen till now. Why? Because we are entering into the main concept in an elaborated way. For that purpose, because I am specifying you in detail here an introduction to IoT. The definition for this particular IoT was: IoT is a network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, actuators, connectivity, which enables all these objects together to connect and exchange the data between these particular things. That is what the definition of IoT was. And the IoT components, which are very familiar to you, such as sensors, actuators, connectivity, data, and application. Sensors, which are collecting the data from environment. Actuators, which are controlling the physical devices. Connectivity, which enables communications. Data, information collected and processed. And applications such as smart homes, smart cities, industrial automation. All these are the basic components which are existent. And this was the block diagram for IoT device, which is having a combination of Raspberry Pi or Arduino, and it is connected to driver circuit, and there is an access point through the driver circuit appliances. And here IoT server and cloud are interacting, and also IoT cloud and PC terminal is interacting, and there are some RF modules and sensor module and power supply which is having a connection with Raspberry Pi kit. Why? Because this Pi kit requires some power supply, right guys? And have a look what are the different kinds of components, which I already told you previously: sensor, processor, communication module, power source, actuator. These are the different types of components which are utilized in IoT system. And have a look. This was a small example which is represented to you in thermostat. This is a smart thermostat where multiple things are existed. With the help of this ham unit, all these devices are functioning. It is maintaining the critical routes. It is maintaining the air conditioning system. It is maintaining the water heater, and it is maintaining the clothes dryer, and it is maintaining the electrical vehicle, and it is also maintaining a particular gateway which is smart meter. All these things are maintained by the thermostat. It is going to send some signals, and the data is going to be communicated with that particular signal through the load controller. As I told you, there are some components: temperature sensor, humidity sensor, processor, communication module, display, actuator. All these are used for the purposes: temperature sensor to measure the temperature, humidity sensor to measure the humidity, and processor which is analyzing the data and produce the heat levels. Either it should be in cool or it should be in heat. Communication modules which are connected with Wi-Fi, and the data transfer has to be transferred between these units, and display current, temperature, set points, and other information. Actuator controls the heating, cooling room. All these are the different components. This was the diagrammatic representation for IoT layer. There are 4 layers: application layer, data processing layer, network layer, sensing layer. All these are the 4 different layers of IoT device architecture. In each and every layer, there are multiple things. First, as I told you, sensing layer, which collects the data from the environment. That was the first layer. Network layer, which transmits the data to the cloud and to other devices. That was network layer. And coming to the third one, which is data processing layer, which is going to process and analyzes the data. That is what data processing layer was. And coming to application layer, which provides user interface and interacts with the user. That is what application layer was. And coming to the additional considerations, we need to consider these factors for a better IoT architecture, such as security, power management, data privacy, scalability. Security is required for encrypting the data or giving authentication and access control. And power management, efficient power usage is required, which is crucial for battery maintenance. Data privacy, protecting user data is essential. Scalability, where to handle large number of devices, we require this particular scalability concept. And there are some examples which are comes under IoT device, such as smart homes, wearable devices, industrial IoT, automotive IoT. For everything, I have specified small examples in bracket. Have a look, guys. Yeah. Now we will move to the next thing, which is Arduino overview. And after Arduino, I will let you know about Raspberry also. In this Arduino, which is, I already told you, it is an open source platform. And here it was very easy to use hardware and software. Microcontroller base, which is focused on physical computing. And the popular boards are Arduino Uno and Arduino Nano, Arduino Mega, Arduino Linado. These are the popular boards in Arduino. And coming to Arduino IDE, which is an integrated development environment for performing the programs and for making configuring this the Arduino board. And what are the basic functionalities? Digital IOO, analog IOO, PWM, serial communication. And coming to applications, robotics, home automation, all these things are the application. And coming to Arduino, and this is an open source platform which is used for building electronic projects, which consists of 2 parts: microcontroller boards and shields. What microcontroller boards are? These are the physical brains of your project, where these popular boards are going to configured with the help of Arduino IDE. And by using shields, these are the add-on boards which are provided for specific functionalities such as Wi-Fi, Bluetooth, motor control and sensors. These are the two different types of components which are existed in this particular Arduino. This is the two parts which are related to Arduino hardware. And coming to software, as I told you, IDE, which is an integrated development environment, and also the programming language which is we are using for configuring the Arduino board. This is about two different parts such as software and hardware. Hardware consists of two things and software consists of two things, IDE and programming language in software. Why Arduino is required? It is very easy to use and it is an open source platform. It is having a large community and its versatility is extending its wings in IoT. For that purpose, we are utilizing Arduino. And coming to the things, how to start this particular Arduino, we need to identify a proper Arduino board which suitables our project. And also we need to install Arduino IDE browser in it. And we need to learn basics for simple projects like blinking LEDs and controlling motors to familiarize yourself to that particular platform and exploring possibilities. Once if we are comfortable, dig into that particular complex problems and experiment yourself with the help of different sensors and actuators, guys. This is how you need to start with working with Arduino things. And there are multiple popular projects, for example, robotics, IoT devices, home automation, wearables, art and music. These are the popular Arduino projects which are designed till now. And coming to the next one, which is Raspberry overview. In this Raspberry, as I told you, it is a single board computer which is more powerful than Arduino. And coming to, it runs on a particular operating system called Linux based, which is either we can call it as Raspberry or we can call it as Ubuntu. And it is also having versatile applications such as IoT, robotics, media center, education. And coming to hardware specification, processor, RAM, storage, connectivity options, and programming language, which is Python, C++, Java. And coming to example projects such as home automation, web servers, image processing. These are the different kinds of things which are existed. And coming to Raspberry, I already told you, which is a tiny computer with big potentiality. And this is like a credit card sized computer which packs a surprising amount of power, which is designed to be affordable and accessible for the things. And why can you use with Raspberry Pi? The possibilities are endless. Why? Because here you need to learn the code. Python is a popular programming language which is used for Raspberry Pi. So there are a number of tutorials which are available. So learn those things and start your project. Home automation. You can control lights. You can control by using thermostats, air conditioning systems, and also a number of other devices. Coming to media center, we can build a powerful media to stream movies, TV, and music, etc. These are the things which can be done by Raspberry Pi. And what can you do with Raspberry Pi? We can design retro gaming, we can design robots, we can design multiple IoT projects, we can design web server on your own. And what are the key features? It was low cost, small size, versatility, GPIO pins, and community. These are the key features which plays a major role in Raspberry Pi, guys. And have a look, guys, what are the different kinds of Raspberry Pi models. The popular Raspberry Pi models are available in the market. Have a look, Raspberry Pi 4, which is a latest model which offers impressive performance and features, and Raspberry Pi Zero and Pico, which is smaller and most affectable often for the basic projects, and Pico, which is a smaller scale projects which is utilized. And this was the differentiation between Arduino and Raspberry Pi by considering 5 features such as processing power and memory, operating system, cost, and typical applications. These are the different features which I compared in both Raspberry and Pi. Coming to processing power, it was low in Arduino, it was high in Raspberry. Coming to memory, it was limited in Arduino and it was more in Raspberry Pi. And coming to operating system, there will be no operating system in Arduino, and there is operating system in Raspberry, which is Linux based, which I already discussed with you. Coming to the cost, it is very low. Coming to the cost, Raspberry Pi is a little bit high, but it is a good one. And coming to typical applications, here only sensor based projects and simple automation will be done. And by using Raspberry, we can do complex problems also. Robotics and computer vision can also be implemented. When to use this Arduino? For simple projects, low-cost solutions and sensors-based application, Arduino is preferable. When to use Raspberry? Complex IoT process and also requires more processing power and memory running operating systems. You can opt for Raspberry Pi. And what are the interfaces which are used in sensors? There are sensors and actuators. Sensors, temperature, humidity, light, motion, distance, all these comes under sensors. And these are used to interface with Arduino and Raspberry Pi. Actuators. Actuators are having number of types like LEDs, motors, servos, relays, etc. And by using libraries and functions, it is easy to control these things. And coming to communication protocols, which are optional, serial communication, SPI communication, I2C communication, Wi-Fi, Bluetooth, Zigbee, these are optional things. And coming to real world applications, such as where we are showcasing our diverse of IoT applications such as smart home, agriculture, healthcare, industrial automation, environmental monitoring. All these are the showcase diverse applications in real world. And what are the challenges which we are going to face? The first challenge was security. Why? Because we need to protect the data. The next one is privacy, which is the data has to be handled with responsibility. Power consumption, which optimizes the battery life. Interoperability, which enables the seamless communication between devices. Scalability, which handles the large number of devices. Emerging technologies, AI, machine learning, edge computing, and blockchain. All these are the emerging technologies, guys. And coming to the endpoints, what IoT device was, what endpoint was, differentiating between two, and what are the devices and endpoints. IoT devices are the things, the physical devices with sensors, actuators, and connectivity, which I discussed so far. Endpoints, digital representation of IoT devices where the data is going to be processed and managed. This is about IoT devices and endpoints. What a clear distinction was, in IoT device there will be a physical entity and there will be data generation and there will be limited processing. This is about a particular IoT device. The particular example for these IoT devices are smart thermostats, wearables, industrial sensors. These are the best examples for an IoT device. And coming to IoT endpoints, what an endpoint was, which is used for digital representation process and also for data processing and also for communication. The best examples for these endpoints are cloud servers, mobile apps, gateways. All these are used for controlling the things and for processing the data and for preparing the decision making systems. And coming to the next one, which are the examples in IoT devices: smart homes, thermostat, smart lights, door locks, security cameras. Coming to wearable, smartwatches, fitness trackers, health monitoring systems. And coming to the next thing, IoT devices which are related to industrial sector: temperature, reserve, vibration, motor. All these are industrial IoT things. And coming to the endpoints, in cloud platforms, AWS, Microsoft Azure, GCP, Google Cloud platform. And coming to mobile applications, smartphones which are used controlling IoT devices, wearable devices for companion apps, IoT gateways, which is the devices which bridge the gap between IoT device and network, data analytics platform, where software is going to be processed and analyze the IoT data with it. And the devices, endpoint and relationships, smart thermostats, wearable fitness tracker. These are the devices, endpoints and industrial sensors which plays a major role. And coming to the role of installation of these IoT cycles, installation is a critical phase in IoT device. Why? Because it is the one which bridges the gap between manufacturing and operational stages. Here, key roles which are played in at the time of installation was physical development. In physical development, we need to correctly place the device in intended environment. We also ensure the optimal sensor which has to be placed properly for accurate data collection. A proper mounting and securing this device is taken care. And coming to configuration and setup, initializing these device settings and parameters, connecting this device to a appropriate network with the help of Wi-Fi or cellular network, whatever you can choose. And coming to configuring communication protocols and data transmission settings, all these things will place in configuration and setup. And coming to integration with systems and users on board, and integration with system, we are connecting a device to other components and we are ensuring a seamless data flow, and also we are integrating a device into the existing IoT system. And user onboarding, we need to provide a necessary information or instructions and support the device operation. We need to enable users to interact with the device effectively. We need to ensure satisfaction and understanding of the device functionalities. This is how users are going to be onboarded. Security implementation was the next thing, and testing and validation was the next thing. We need to provide security. We need to control and authenticate mechanisms. We need to protect the device. That comes under security implementation, and verifying the device functionality and performance of the installation. That can comes under testing and validation. What was the importance of effective installation was in effective installation the major things such as optimized device performance, enhancing data quality, reducing trouble effects, improving user experience, strength secure position. These are the important factors which has to be considered at the time of effective installation purposes, guys. And coming to the next one, I already told you, for transferring the data, we require a time-sensitive applications and predictive maintenance. That are the things which plays a major role at the time of real-time data transfer. Time-sensitive applications are the things which where the data is going to be processed and act accordingly, and where the predictive maintenance by rapidly analyzing the sensor data, equipment failures can be predicted so that we can prevent costly downtime effects. Scalability, growing networks due to the n number of IoT devices growing in the network. So we need to handle and increase the data volume. Flexibility development. So we need to provide flexibility for communication, reliability, a continuous operation which has to be provided for crucial environments when downtime is unacceptable. So which ensures a continuous uninterrupted data flow with this continuous operation and reliability so that users will trust us. Integrity, data integrity, which is efficient protocol which is used for error control mechanisms for protecting the data from corruption due to transmission. This is for reliability. And coming to energy efficient, where battery powered devices are limited power devices which are efficient communication protocols which helps to conserve the energy by minimizing the data transmission overhead. We need to extend the battery life by reducing the maintenance cost, and also security. And in this security, data protection and privacy will play a major role. Cost effectiveness was the next factor where we need to take care. Here in cost effectiveness, we need to utilize resource utilization, and we need to improve the system performance. Resource utilization was where we are reducing the network congestion and hardware requirements, and also which leads to lower cost, and where we are improving system performance because faster data transfer and reducing latency automatically improves the system efficiency. This is how the cost effectiveness will be improved. What are the different kinds of user interfaces? Graphical user interface, command line interface. These are the different kinds of interfaces which are utilized. GUI, which uses visualizing elements like icons, menus, windows for interaction. The best examples are desktop operating system and mobile apps. CLI, which is a command line interface, text-based interaction with commands like Linux terminal and command prompt. These are the GUI and CUI interfaces. And the next one is menu interface. Here we are presenting in form of menus by using user selection, such as ATMs and vending machines are the best examples for menu driven information. These are the three different types of interfaces which are presented. Coming to user interface, natural language interface which we are utilizing in it. Best example was voice assistant and chatbot. And coming to the touchscreen interface, which allows us directly by using smartphones or tablets, we are connecting with chatbots, right? That is how user interfaces. Coming to hardware interfaces such as serial interface, UART, SPI, I2C, which transfers the data sequentially one bit by time. And coming to parallel interface, which transmits multiple bits simultaneously. And network interface, which connects the device to a network. This is about the network interface. Coming to sensor, which connects the sensors to a system, analog to digital converter or digital to analog converter. These are the sensors. And coming to software interfaces, API, application programming interface. Here we are defining the software components, how to interact. GUI, graphical user interface. We are providing building blocks for creating GUI. Command line interfaces. We are offering functions to interact with the command line. Database interface, which are allowing interactions with database. And what are the other types? Brain computer interface. We are using this brain computer interface to connect with the brain to a computer. HMI, which is a human machine interface, which facilitate interaction between humans and machines. And serial communication interface, I already told you, UART, which is a basic concept in serialization. This protocol is used for structuring the data flow and the data transfer. What are the advantages and disadvantages? These are the things which I am going to discuss with you in the next class. And coming to serial communication, which is UART, which is a simple asynchronous transmission of data, which is done in the short range data transmission. And what exactly this SPI communication was, in this SPI communication, we are going to discuss about SPI protocol, advantages and disadvantages, different use cases. What SPI communication was? It was a asynchronous serial communication protocol which is used for short distance, often uses high speed data transfer. And coming to the next one, I2C communication. In this I2C communication, the same way we are seeing different use cases, advantages and disadvantages, and I2C protocol, multi-master slave protocol. What I2C communication was, which is a multi-master serial communication bus for connecting the low speed devices. That's it, guys. In the next class, I am going to discuss in detail about these communication interfaces, much more. We'll meet in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.